Hi, my name is Dr. Michael Batu and I'm back. And today we're going to continue where I left off in the previous video about consumption and saving function. But for this video, what I'm going to do is I'm going to give you a numerical example right here. Suppose you're given a graph that looks like this, right? So you have the consumption function right here. And we have information on the different amounts of consumption. Okay, and I'm going to add some value here. Let's add here 500. I forgot to add this, so it's 500 right there. So it looks like this. You have the 45-degree line and the amount of consumption and national income where the 45-degree line intersect the consumption function. So we're given this, and we're asked to derive the consumption function. Well, let us first recall what the consumption function looks like. Well, let's assume that disposable income equals national income. So it should look like this. Okay. Now, there are two things that we need here. The first thing that we need is this guy. This negative, sorry, not negative, it's C sub 0. It's not negative, so it's just C sub 0. So the first thing we need is the C sub 0, and the next thing we need is B. Okay, so remember, C sub 0 is autonomous consumption. Okay, you don't have the negative here, it's just C sub 0. And then the B here is your marginal propensity to consume. Well, we know that C sub 0 is the amount of aggregate consumption expenditure when national income is 0. Now, let's look at the graph again. If national income is 0, question for you, what is the level of aggregate consumption expenditure? Well, from the graph, it's there. If y is 0, what we see is that consumption is equal to 500. So when y equals 0, we know from the graph that C is equal to 500. So therefore, C sub 0 is equal to 500. So now we have C sub 0. The next thing we need is B. Remember, by definition, that B is equal to our change in C over change in Y. And this is our marginal propensity to consume. Well, we have the information that we need to find change in C over change in Y. Let's look at the graph again. So when income is 1,000, consumption is 1,000. If income increases to 3,000, consumption increases to what? 2,000. So we can say the following, that our change in C is given by the difference between 2,000 and 1,000, and our change in Y is given by the difference between 3,000 and 1,000. So let's use this information right here. So therefore, from the graph, we know that B is equal to 2,000 minus 1,000, that's our change in C, over 3,000 minus 1,000. And that gives us 1,000 over 2,000, which is equal to 1/2 or 0.5. So we can now assemble our consumption function from the information from C sub 0 and B. And this is how it should look like. So the consumption function is C is equal to 500 plus 0.5 Y. And that's how our consumption function looks like using the information from the graph. Now the next thing we're going to do is we're going to derive the saving function. All right, so now let's derive the saving function. So we know by definition that saving is y minus c. So all we need to do is just to plug this consumption function right here. So we have y minus 500 plus 0.5y. And we get negative 500 plus 0.5y. And that is our saving function. Now, I should also say the following. Remember from the previous video that the equation or the expression for the saving function looks like this. S is equal to negative c sub 0 plus 1 minus b times y. Remember that this b is marginal propensity to consume. The 1 minus b is actually what we call the marginal propensity to save. Okay? So again, b is our MPC, marginal propensity to consume. 1 minus b is our marginal propensity to save, which is this guy. And that concludes our video on consumption and saving function. I hope you learned something, and I'll see you next time.